All right, quick backwards. This is for the 3 people that will ever watch this recording. If you need to find the information about how the solar system was formed, you can look at the PowerPoint in the folder for the Notes 1. We talked about what's the driving factor behind all this. It's gravity. Gravity is the thing that seems to kind of pull everything together, literally and figuratively. So why do we see differentiation? So let's talk about what we actually do see. We see that rocky things are near the center. We see the icy things are out near the edge. We have gassy things in the middle. So what are some possible explanations? How do we explain this from what we know? Someone start me off. Look at them all, eager and willing. Love it. Miley, let's start with you. Give me one thing if you can tell me about the differentiation of the solar system, why it happens, what we know about it, something like that.
I don't really know if this was explained on how it comes and everything, but I have like that high temperatures and warmer regions of the cloud.
Good. Tell me about it.
It caused gas trains to break apart in molecules which in turn split into excited atoms.
Good. So high temps, closer in. Say one more time what you said about the last bit.
The gas trains break apart in molecules which in turn split into excited atoms.
Good. So high temp closer in. That causes dust grains to split apart. And form atoms. Now, the atoms that you're going to have at that point are things like hydrogen and helium really close in, and that's going to form the sun. As you go further out, those dust grains and the particles left over will be different things that you have, depending on where you are in the solar system. Good. And again, the high temps are really important when you're talking about closer in. In fact, I think it says, where we talk about, yeah, so talking about where Saturn was only about 100 Kelvin, as opposed to where you're in closer with much, 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 much higher temperatures. So you can see how there's a big difference there. Good. Michael, give me something else you can tell me about differentiation of the solar system. What's going on there?
Stuff bouncing off each other.
Okay, so there's a lot of collisions. Tell me how that makes stuff happen.
Stuff bouncing into each other causes different directions for different objects.
Okay, good. So the collisions, they can cause the direction of the motion or orbit. Good. Michael, part 2, the return of Michael. What you got for me?
Stuff in the outer regions remained intact when the stuff in the inner parts disappeared.
Yeah. And this is stuff like ice and gas. That stuff didn't get ripped apart. Yeah, stuff that is further out, that stuff didn't get ripped apart. So icy things stayed together far, far, far out because they weren't in these high temperatures where they're getting split apart in atoms. Okay? Gassy things further out, like where Saturn was, where it was 100 Kelvin. Okay? Gassy stuff can make it in 100 Kelvin. Gassy stuff gets ripped apart when it's in closer. Good. And so, speaking of that, talking about now, so in close, only heavy elements so this is stuff like iron, silica, that kind of stuff. Only that kind of stuff survive. Survive's not quite the right word, but that is the word that's used by a lot of astronomers. That's the stuff that wasn't kind of getting ripped apart. And so that helps us understand this idea of the formation of the solar system. And the reason we don't still see that stuff is because the solar wind pushed, that's not a P, pushed excess stuff to the edge of solar system. Okay. Eventually, so this stuff that kind of got ripped apart, it eventually reforms, but it's only going to be the heavier stuff that's left. Okay, everything else would have gotten pushed out of the center of the solar system. Okay, so it's only the heavier stuff that would have formed there at the end. So we kind of get this region. We got the sun in the middle. This region in here, this is going to be kind of your rocky, heavy stuff. That stuff was heavy enough not to get pushed all the way out on the solar system when the sun started fusion. After that, you get kind of the gassy stuff. That stuff survived out in that region where the temperature was. And then really far out, then you have the icy stuff.